Hello and welcome back to RC Model Reviews. Now, I did a review of the, what is it? I don't know. RC700D LCD monitor DVR diversity receiver yesterday. I put it up, part one of that review, and I noticed, well, I showed you how when the voltage got down to 7.4 volts, the whole thing got a bit hissy and hiccuped and went off and on and so forth, rebooted. And I thought, you know, I did it twice because I wanted to be sure that I hadn't made a mistake, and it did the same thing as many times as I tried. And then in the comments on that video, someone said, hey, I've got one of these and it doesn't do that. So I thought, have I made a mistake? And I don't know, when I make a mistake, I like to fix up, not cover up. If I do something wrong, or if I make an error, I like to correct it so everyone knows the facts. And you know, if I've made a mistake, then I'd rather you knew about it and you knew what the real situation was than to simply cover it up and pretend that I hadn't made a mistake and have everyone think, oh, he's so clever. No, I'm not clever at all. I'm completely human. But when I put that on the bench there, and the guy said, well, hey, you know, mine doesn't do that. I thought, hey, I wonder if I've made a mistake, because using my bench power supply, and the bench power supply, if you look at it, you'll see it's got two knobs. One adjusts the voltage and the other one adjusts something called the current limit. And that's designed so that when you're testing a piece of equipment on the bench, if something goes wrong and you get a short circuit, it won't just try and dump all the available current into the circuit and cause smoke and flames. It will actually limit the amount of current. So it'll say, whoa, whoa, slow back, and it'll drop the voltage down until the current that you've set as a maximum is maintained and not exceeded. So I thought, I wonder if I accidentally left the current limiting on so that when the voltage got down and the current draw of the LCD went up, it triggered the automatic current limiting, and that would have caused the voltage to drop and the whole thing to shut down. I thought, ooh, I may have done that. Now look closely at the video, and there's a little red light on the front of the power supply which lights up if it goes into what they call the constant current mode, current limiting. And I couldn't see that light flashing or lighting up, so I thought, well, it's probably not going to be that. I'm pretty sure that I've left that turned up, but I'd better put it back on the bench and test again just to make sure I hadn't stuffed up. So that's what I'm going to do now. So join me and we'll have a look. Okay, here are the two knobs. This is one labeled voltage, this one's labeled current, as I said. And you can vary the voltage with this knob, and you can vary the point at which the current limiting kicks in. So if you don't want anything to draw more than 2 amps, you can set this so that the power supply, when it gets to 2 amps, will start winding down the voltage if the amount of current increases. So it's a bit like your battery charge. You know, when you put your LiPo on, it goes up and it sticks at a certain current, whatever you've set the charging current at. Well, that's the way this would work, constant current. So you can actually use this to charge batteries if you want to, but you've got to be pretty careful. So anyway, I've obviously checked and I've wound this right up. It's wound right up to the maximum so that there's no current limiting. The only current limiting is the actual 5 amps, which is the maximum this thing can deliver anyway. So that's a built-in maximum already. And this LCD is only drawing 1 1/4 amps. It won't draw anywhere near 5 amps. But I'll show you something that's quite interesting. Now, if I wind the voltage up, this voltage up here, you watch what happens to the current. The voltage is going up. We're up to 9 volts and 10 volts. And this current is going down. In fact, if I go up to 14 volts, let's say we take it up to like a 4-cell pack, which is nominally 14.4 volts. Here we go. It's dropped down to 0.6 amps. It was 1 1/4. Now it's half of that. Because I've doubled the voltage, I've halved the current. How does that work? Well, it's because these power supplies in the LCD is a switched mode power supply. I've spoken about those before. And basically the LCD is always going to draw a constant amount of power. Now the power is a combination of the voltage and the current. If you multiply the current times the voltage, you get the power. I'm going to do a little calculation here with my trusty calculator because my brain's really rusty. I've got 14.6 volts here. Well, let's actually take it up to 14 volts. Try and get it right on 14 volts. It'll make the calculation. No, actually I'll make it 16 volts. Make it really simple. 16 volts. Here we go. Yeah, I want to get this as accurate as I can. There we go. That's close enough. 16 volts, and it's drawing 0.59 amps. So 16 times 0.59 equals, that's 9.4 watts. If you can see on my calculator here, that's the power. That's the power that is going into our LCD. So now let's take that voltage down to 8 volts and see what happens. Here we go, down to 8, 10, 9. Get there eventually. Oh, it's always a little bit dicky. There we go. So that's close enough to 8 volts. Now what I'm going to do is I'm going to multiply 8 times 1.34 equals, and as you can see, it's a little bit more, it's 10.7 watts, but it's not much more than the 9 point something or other watts we got before. The amount of power being consumed by the LCD hasn't really changed much, even though we've halved the voltage. It's actually gone up a little bit, if anything, because it's less efficient at the lower voltages. But there you go. So when we raise the voltage, we reduce the current. When we reduce the voltage, we raise the current. What I was concerned about when I did that video yesterday was that perhaps because as I was winding down the voltage, the current was coming up, it was enough to trip the current limiting. And that's why the LCD may have been stopping, because the current was being limited and therefore the voltage was dropping, and it was going into a mode called foldback, which is when the switch mode power supply shuts right down. Because once it shuts right down, it's not drawing any current, so the voltage will come back up, so it will reboot, and then of course it's drawing current, so it will shut down. So all those things create a fairly common situation with a switch mode power supply called hiccuping or foldback, and that's what I thought we might have been getting. But I'm going to continue winding down the voltage here, and I want you to watch, see if the little red light comes on. I don't think it will. Down to 7.7, 7.6, 7.5. The screen is now stopped. Let's see if we get a flicker on that. No, we don't. And what I've done here is something just as important. We'll go over to the oscilloscope and have a look at that. Right, now I've got the meter and the oscilloscope in shot, and the oscilloscope's actually measuring the voltage. If you look at the yellow line as I wind the voltage up, you see the line go up. It's telling me what the voltage is. And you see the voltage goes up on the meter. The reason I'm using the oscilloscope is because if this was going into current limiting mode, then the voltage may drop very quickly, but only for a very short period of time. Our meter wouldn't show that. It's not quick enough. You notice that when I change the voltage, the meter takes a while to respond, whereas the line on the screen responds immediately. So by hooking the oscilloscope up here, we'll be able to see if there's any sudden drop in current that might cause the screen to hiccup, sudden drop in voltage, I should say. So I'm going to unplug it, and it's just all noise on there, don't worry about that. Turn it back on again, and the screen comes back on. There we go, we're drawing 1.125 amps as we were before, and there's our voltage up here. It's nice and steady. I'm going to wind it down slowly, and I'll tell you when the screen stops working, and we'll see if there's a sudden dip in that voltage there. So we'll wind it down. Here we go, 8 volts. 8.6, here we go, it stopped. Now did you see the line trace move? It didn't move. There's actually a little bit of, as it's hiccuping, you can see there's actually a small change in the voltage there because it's putting extra load on the power supply, but it's certainly not enough. It's not actually causing the power supply to go into current limiting. If it was, then that would be a significant drop in the voltage there, so nah, it's not happening. And just to make sure, I'm going to wind up the current limiting to maximum, and so no, there's no current limiting going on there at all, and it's still, the screen is still going through that hiccuping off and on rebooting mode. So I didn't make a mistake at all. It was as I said, but what I'm going to do to verify this, to triple check it, I'm going to put a 2-cell battery on here. I'm going to run it until it stops working, and then we'll measure and see what the battery voltage says, just in case I made a mistake again, but I can't see it myself. Okay, let's do some more testing. I've got the 1000 milliampere hour 2-cell Turnigy LiPo. This one's rated to 30 to 40 C, so it's, it would probably even fit in the back of the thing, but it's only 1000 milliamps. I've got a bit of charge in it, not a lot, because I don't want to wait for a long time to see what happens here. I've got my multimeter connected up here, and it's reading just some random voltage at the moment because I have nothing connected. So I'm going to plug in the battery. I've got this bit of the screen, you'll be able to see what happens down here to the screen. Plug the battery in, we'll keep an eye on the voltage and see if it works when I do so. Here we go, plugging it in, and there we go, the screen starts up. Voltage is 7.5 or 7.47 volts, so that's going to be pretty good. What I'll do is I'll leave this here, and that voltage is dropping down pretty quickly, and we'll see if the screen stops working when it gets to 7.4 something volts, maybe a bit under, because that's what happened on the power supply. I don't think it's going to take very long because there's quite a high current draw, and if this thing is going to stop at just under 7.4 volts, it will, there we go, it's just done it. It's hiccuping again. If I go down to the display, we've got 7.3 volts, and the screen's going off and on. So it's not a factor of the power supply. It's actually when the voltage of the battery gets down below about 7.4 volts, the screen has a hissy fit. However, now I'm going to show you something quite interesting. I've plugged the lead they give you into the DC barrel connector. So I've disconnected the battery from the actual battery connector, and I'm going to plug it in through the power connector on the side, and we'll see if it works when I do that. Here we go. Voltage 7.5, and the screen has started up. I'll try and keep them both in shot. There we go. Now we're down to 7.3 volts, and the screen is still going. And let's see what happens. So when the battery is connected to the internal battery connector, it stops at 7.4. When it's connected to the external power jack, we're down to 7.3 and it's still going, 7.29. We'll just wait a few minutes and see what happens. See how low it has to go before the screen stops. Okay, here we go. This is getting really interesting now, because if you look, we're down to 7.2 volts and the screen is still going, only when I power it from the external connector. So there's obviously a lot more voltage drop when you connect your battery to the internal connector than there is when you connect it to the external connector, which is kind of strange, isn't it? It's kind of silly. And we're still going at 7.2 volts. I wonder when it will actually stop. I'll just leave it going and we'll see what happens. And while we're waiting for that to happen, it's worth noting we've got 7.18 volts on the fluke meter. But if I go down onto the LCD, it actually says 6.5. So we actually have about 0.7 volts difference. And that's when we use this external power jack here. 0.7 volts difference between the actual voltage and the displayed voltage. Now, when we use the internal battery, we have 1.5 volts difference, which to me indicates that the path for the power from the internal battery has to go through 2 diodes. The power from the external source only goes through 1 diode. So that's why we can run on a much lower voltage when we plug into the external power jack than when we use the internal battery. It's kind of crazy, really. I think Skyzone should look at that and see if they can fix it, because it really does slightly reduce the utility of this particular LCD display. Well, here we go. Some time has passed. The voltage is now down to 7.09. I have a feeling, and it says down here 6.4, so there is, there's about 0.6 to 0.7 volts difference between the two. And I have a feeling this will probably keep going until it's under 7 volts. So it works fine on a 2-cell pack if the 2-cell pack is plugged into the external power port, but not if the 2-cell pack is plugged into the internal JST connector. And quite honestly, I don't like to take 2-cell packs down much below 7 volts anyway, because that's 3.5 volts per cell. And if you discharge a LiPo pack too deeply, that's what causes them not to last long, and it can also cause them to puff. So yeah, down to 3.5 volts per cell is all you really want to take them to if you want a long life out of your LiPos, and this one's still working at 7.08. There you go. So maybe if you want to use the internal battery, you should rewire the inside of the LCD so that the JST connector is actually across the little barrel jack that we're currently using, and then you'll get some really sensible life out of your 2-cell battery. But don't plug an external power source in at the same time, or you could have smoke on your hands. So there we go. I was really prepared to fess up if I'd stuffed up, but I didn't stuff up. The observations here have been proven, well, the ones I made yesterday have been conclusively proven again by checking all the possible things that could have gone wrong today. So yeah, the internal battery only works down to about 7.4 volts. Externally, what are we going? We're still going here, 7.04, and the LCD is still going. You probably, I don't know, probably see it in the background here. Still going. So yeah, crazy. Hope Skyzone address that. I hope they fix it up so that we can really use that internal battery compartment for some 2-cell packs and get some reasonable use out of it. Anyway, there you go. Any questions, comments, put them on the bottom. This isn't part 2 of the review. It's just an add-on, because even I was concerned that I may have made a mistake. And so stay tuned. In the next couple of days, weather allowing, we'll have plenty of video. I'll show you how this thing works out there in the bright sun. Bye for now. Time to get, you know what, back to the bench.